I would like to introduce you to the Telestack TCL1031 track-mounted stockpiling conveyor. Telestack make a wide range of track-mounted conveyors from small sand conveyors that handle 50 ton an hour, 100 ton an hour, 200 ton an hour, right up to this machine. This is the largest track conveyor with mid-mounted tracks that Telestack manufacture. Now this just isn't your normal track conveyor. This is a conveyor which is designed to work after primary crushers. So in applications where you've got a mobile primary jaw, high capacity, high tonnage jaw, kicking out large rock, this is the conveyor that you need. The TCL1031, as the name suggests, it's a 1031, so it's a 1,000 ton an hour, 31 metre long conveyor. When it's fully raised, that gives you a stockpile height of up to about 12 metres. The machine itself, very versatile, very mobile. It's got a diesel engine, hydraulic driven tracks for moving it around. So the engine is used for movement, relocation and setup. The particular model that we have here is a hybrid machine, so we've also got electric power on the machine. You might notice at the head of the conveyor we've got 2 electric motors, so whenever the machine gets into position using the diesel engine, we switch over to electric power. Typically the type of crusher that feeds this machine is an electric machine, maybe a generator on board, and generally there's excess power to run the unit. If we can take the power from that primary crusher, we obviously save on wear and tear in the engine, we save on fuel, reducing diesel consumption and reducing overall production costs. The TCL1031 is designed for 0 to 300mm up to 12-inch rock. It's a very, very heavy duty design, a heavy lattice frame conveyor, all the steelwork, heavy gauge steelwork, full impact bed onto the feed hopper. The feed hopper itself manufactured from 12mm plate, half-inch plate, with liners, fall brake and under hopper support frame. The 1031 comes with heavy duty fixed end rollers. So we've got 5-inch, 125mm heavy duty rollers which carry the product up the belt and drop it off at the discharge point of the machine. Okay, so we're at the feed-in point of the TCL1031. The TCL1031 has a hexagonal shaped feed hopper, extended, a very, very large feed boot. It's this machine gets fed by large primary crushers with discharge belts of 1.4, 1.6 meters, but this hopper has no problem taking that width of a belt or that surge from the primary crusher. The hopper itself, extremely heavily built. It's manufactured from 12mm plates, so half-inch 6 plate. It also has 12mm liners, hardened steel liners on the inside there. Also a fall brake running right up the hopper, so whenever the rock is coming down, it hits the fall brake, drops onto the side before it goes down onto the belt. The belt itself is a EP 800 5-ply belting. Underneath that belt we have a full impact bed in the hopper. So it's just not your standard rollers in there, you have a full impact bed, so whenever the rock hits the belt, it's not going to puncture through the belting or damage the rollers that's underneath. So the machine itself is designed for 0 to 300mm up to 12-inch rock at production rates of up to 1,000 ton an hour. Very important feature of the machine is the hopper can be hydraulically height adjusted. So whenever we extend this machine fully up, the feed-in height is just over 4 meters, but whenever we take it down to its lowest position, that comes all the way down to 2.2 meter high. So if you have a very high primary crusher with the high discharge belt, the feed hopper can go right up real close to the belt so that product isn't dropping high distances down into the hopper. It's the drop height is minimized. You can appreciate if you have 800 ton an hour, 700 ton an hour of heavy rock coming over the crusher into the conveyor, there's a lot of stresses and strains in around this end of the machine. So the overall steelwork on the machine at this end is very, very heavy gauge. We also have hydraulic support legs here. So these raise and lower, but whenever you get into position, you drop those legs and they give the machine support at the tail of the machine. The telescopics at the rear as well are also allow the machine to raise and lower. So you've got hydraulic telescopics back here, we've got the support mechanism here, heavy duty steelwork. Overall, this is one of the most robust, strongest hoppers that's used on track conveyors in the industry. So if we look at the head of the conveyor, or the discharge end of the conveyor, where the material comes off when it's in its stacking position, here we've got a 1.2 meter wide belt, or a 48-inch heavy duty conveyor belt. We've got twin drives on the conveyor. The machine here is electric, so we've got Nord drives with two 22 kilowatt drives, or 30 horsepower. One of these drives includes a backstop, so whenever the conveyor is in its working position, we run back down the conveyor belt. The backstop holds the belt in position. We also have a real good quality heavy duty primary belt scraper on the conveyor here for cleaning your belt. Spring mounted, interchangeable sections here, very important for the customer. As one of these sections wears out, it's easy replaced and cheap for the customer to replace that component. So we've got the head of the conveyor right down here in the lowest position. Obviously in a stacking position, that raises all the way up to give us a 12 or 13 meter discharge. If we focus on the side profile of the conveyor, it's the heaviest duty stacking conveyor on the market. We've got a hydraulic top fold, so you can see that we've got a hydraulic cylinder here which flips this section over whenever we want to take this machine into a transport position. So that makes the machine more compact for moving. The steelwork on the conveyor, heavy duty steelwork. You know, the telescopics which lift this conveyor, elevate this conveyor into position. We've got 200 by 200 really heavy duty box section. So that takes the load from the conveyor right down into the heavy duty chassis. The framework in the center section, you know, deep framework, 900 millimeter, 3 foot deep frame section to take the stresses and strains of large primary rock, 300 millimeter rock going up the length of the belt. In onto the machine here, you can see the telescopics. We've got 3 heavy duty hydraulic rams that lift the machine and elevate the machine into the working position. Another real neat and nice feature of the 1031 is the stabilizing blade mounted just after the tracks. So we've got 4 meter long tracks on the conveyor, but when that machine's up and in its fully raised position, you can imagine that stability is very key. So we've got a hydraulic push down stabilizing blade which comes down onto the ground, pushes down firm, and that gives the machine an extra stability. So in actual fact, on the ground you have a 5 meter long footprint to keep that machine stable. So let's look at the tracks in the chassis and power unit area of the machine. First of all, looking at the tracks, these are FL6 heavy duty tracks. This machine is almost 30 ton weight, so these are the upper end of the tracks that we use within Telestack. These are a real heavy duty unit, ideal for working in quarries, for tracking over long distances. 4 meter centers gives us the stability when we're moving the machine over rough terrain. Heavy duty beam, robust track system. The power unit itself, along each side we have 3 lockable doors, so very important for customers that they can secure their machine at night. We've got keys, lockable units here that the machine can become secure. Access to the machine, open the door, excellent access, excellent for serviceability. We've got a 200 litre diesel tank. The cap, very accessible position, easy to fill for the customer. Hydraulic tank mounted beside it. Again, the lid is here, so it's very easy to fill, easy for maintenance, easy to get in and see what's going on. Coming across to the main power unit door, again, easy to get in, ease of access, and access to the engine totally unrestricted. From this point, we control, these are the hydraulic levers on the machine, and this is where we can control the machine for setup. You know, raise and lower head, raise and lower tail, flip over the head, and raise and lower the other end of the machine. Also set the jack and legs at this point. So as you can see, loads of space, loads of access, easy to get in there. The same on the other side. Inside the power unit we run a Cat engine. It's a C4.4, 98 kilowatt, 130 horsepower engine. Heavy duty cast iron pump, heavy duty pipework, all top quality components. Of course, in this particular machine, as it's electric drive, the engine and the hydraulic system is really only used to get the machine into position and to get it set up. Once you're in position, you kill the engine, plug in your electric power, and the machine runs in electric mode. So if we focus here on the panel on the machine, So the unique feature of this machine is it's a diesel engine machine, which is used for the diesel hydraulic system is used for movement, relocation and setup. But we have the ability to connect up to electric power to run the machine from electric power supply. That power supply can come from the mains electricity supply, or it can generally come from a primary crusher. So when we're specifying this machine or working with a client, we will work with the crusher supplier and size that crusher appropriately, and then we'll bring a power supply into this 125 amp plug. So if we look at the panel here, it's inside a double skin enclosure. So we've got a perspex screen here, and we can see quite clearly what's going on inside on the panel. Access to the panel, very easy. Just turn these units, that gets us right in, and we can start, stop, control the machine from this location. Inside the panel itself, if we look at the panel, we've got an isolator switch here for isolating the machine when you need to work at it, and then we can easy access to the unit, and that allows us right in here to access the body of the control system. So the control system that we use here is a high deck with a TT controller, fully enclosed unit, pre-programmed. The box here, very open design, so very, very user friendly. Customers particularly like this design of a panel. Easy to fault find, easy to see what's going on, easy to change and replace units within the panel. In the box, we've got a drainage plug, so if any moisture gets into the panel, that's drained out. We've also got a breather here to let a little bit of airflow into the machine. So here we have this is the service side of the engine. So large open canopy, loads of space, loads of room. Customers really like this design of a machine where there's good access to get in, to carry out work and to carry out maintenance. So we've got our diesel filter, we've got our dipstick, and we've got our engine oil filter. So very easy for customers to get in to carry out maintenance and service on the machine. We've also got our air filter at this point, which is again easy to access. Within this part of the machine, we also have the hydraulic oil cooler, which the oil is pushed through this oil cooler for cooling purposes. So in cases where the oil goes above 60 degrees, the oil cooler kicks in, and that cools the oil within the machine. Introducing the Telestack TCL1031 in a working quarry. In February 2018, Telestack installed a TCL1031 for Skanska at their Viken quarry close to Gothenburg in Sweden. This quarry became globally known as the world's first emission-free quarry when Volvo Construction Equipment, in partnership with Skanska, operated unmanned dump trucks, hybrid excavators, wheel loaders, as well as fully electric excavators in 2018. On the site, Skanska operate a high-capacity 140-ton jaw crusher, producing 0 to 300 mm product at production rates of up to 600 tons per hour. Previously, material was discharged direct to ground from the tail belt of the crusher. Cat wheel loaders were employed to constantly remove the product from the crusher discharge belt. The TCL1031 includes a diesel engine for relocation and setup. It is fitted with electric drives on the head of the conveyor. So when in position, electric power is taken from the crusher generator to power the belt on the TCL1031. So only one engine is used to run both machines. By introducing the Telestack TCL1031 after the jaw crusher, the stockpile height of 4 meters was increased to 12 meters. By introducing the Telestack TCL1031, the following advantages are achieved. Wheel loaders for stockpiling removed. Stockpile capacity increased by 4,400 tonnes. Lower production running costs. Reduced noise on the site. Reduced dust emissions. Reduced crusher idle time. Increased tonnage. Much less fuel requirements. Comparing a TCL1031 31 meter conveyor to a 24 meter conveyor, we can gain 82% more stockpile capacity.